So, Unit 7 is a pretty short one. We are working with rational expressions and equations. So today, we are going to be reducing, multiplying, and dividing rational expressions. So we're just reducing, multiplying, and dividing. Factoring does come into play here. So, we have two steps we need to go over. Step 1, we are going to factor both the numerator and denominator. So we are going to be using our factoring methods. I have a lovely poster up here to remind you of all of our methods. And then step 2, we're going to simplify or reduce whatever we can. Okay, example 1. X squared minus 2x minus 3 all over x squared minus x minus 6. Okay, so what our first step is, we're going to take the numerator and denominator and we want to factor those. So, looking at the numerator, what method will I use to factor that? The diamond method. So I need two numbers that multiply to negative 3 and add up to negative 2. Negative 3 and 1. So the numerator factors to x minus 3 times x plus 1. Okay, the denominator, x squared minus x minus 6, what method is that? Also diamond method. What two numbers multiply to negative 6 and add up to negative 1? Negative 3, positive 2. Okay, so that factors to x minus 3 times x plus 1 all over x minus 3 times x plus 2. So, somebody asked a really good question. In the beginning, couldn't we have reduced the x squared and the x squared? The answer is no, because notice how in the numerator everything is attached by subtraction, and in the denominator we also have subtraction. Addition and subtraction are like glue. It sticks everything together. So the x squared is attached to the 2x, which is attached to the 3. They're all stuck together, which means it has to stay together. After I factored it, I noticed that on top I have x minus 3 altogether, and on bottom I have x minus 3 altogether. So could I cancel those? Yes, they are exactly the same. So you can reduce those because they're exactly the same. If I see you do this on a test or a quiz, I will be very upset because I get tired of writing "can't do this" a million times on tests. Okay, you cannot do this. Okay, you have to, it has to all be exactly the same, or after you break it up, there's parts that are exactly the same. So then my answer comes out to x plus 1 all over x plus 2. You can't reduce anything else there, so you are done. Example 2, 2x squared plus 10x all over 3x squared plus 16x plus 5. Okay, numerator, we want to factor that. This is not a diamond method, but it does have a what? A GCF. What's the GCF in here? 2x. Good. So factor out a 2x. That's going to leave me with x plus 5 all over. Now in the denominator, I have 1, 2, 3 terms, so first thing I have to look for is a what? A GCF. Do you see a GCF? No. So what method will I use? Bottoms up or over under. So multiply 3 times 5, so that's going to give me x squared plus 16x plus 15. From here, what can I do? Diamond. So give me two numbers that multiply to 15 and add up to 16. 15 and 1. So that comes out to 2x times x plus 5 on top. X plus 1 and x plus 15 on the denominator. Okay, now very common mistake. A lot of students stop here, but I'm doing bottoms up, so I'm not finished yet. What's my next step? Divide by what? By 3. 1 and 3 do not reduce, but 15 and 3 do. 3 goes into 15 5 times. So then we bring the bottoms up. So in the numerator, that gives me 2x times x plus 5 all over 3x plus 1 times x plus 5. We want to reduce where we can. Do you guys see anything that reduces? X plus 5. So that gives me 2x over 3x plus 1. Alright, example 3. X minus 4 on top over x to the third minus 64. I want you guys to look at this. We cannot factor the numerator, correct? Okay, can I factor the denominator? Okay, it is not a difference of 2 squares though. Does anybody remember what method this is? Difference of cubes. Is 64 a cube? Yeah, what times itself 3 times gives me 64? 4 cubed. Okay, so we don't have to worry about the negative because it's the difference of cubes. So on the numerator we have x minus 4. That didn't factor. What was the acronym for factoring cubes? So, right? So set up your 2 parentheses. Same, opposite, always positive. And then let's see how well you guys remember. What goes in the first blank? X. What goes in the second blank? 4. First blank, or third blank? X squared. The middle we do what? 4x. And the last one is? 4 squared. So that's going to give me x minus 4 all over. We have to simplify first. X minus 4 times x squared plus 4x plus 4 squared, which is 16. Do you see anything that cancels here? X minus 4 and x minus 4. Okay, very common mistake, and I want to make sure that you guys do not miss this. This x squared plus 4x plus 16, where is it currently located? In the numerator or in the denominator? Denominator. Does it ever leave the denominator? No. A lot of times I get students that give me this as their answer. And that's their answer. It has to stay in the denominator. So since it's in the denominator, what is in the numerator? A 1. Okay, so make sure that you are remembering the 1. You can't. Remember when with cubes, this long part, it doesn't factor ever. Yeah. Okay, example 4. X to the third minus 5x squared minus 3x plus 15. This looks at least semi-familiar, right? We just did one like this. All over x squared minus 8x plus 15. In the numerator, I have 4 terms, which means which method do I use for factoring? Grouping. So group the first 2 and group the last 2. From the first group, I need to pull out a GCF. What is the GCF here? In the first group, x squared. So that leaves me with x minus 5. What would the GCF be in the second grouping? Negative 3. So that leaves me with x minus 5. We always want to pull out the negative because then it's going to change the sign. All of that is over. What method can I factor the denominator? Diamond. So what 2 numbers does it all come out to? Negative 5 and negative 3. Okay, we are not done factoring the numerator, so you can't start canceling anything yet. Remember, x minus 5 is now our GCF, so pull it out. So that's going to give me x minus 5 times x squared minus 3, what's left over, all over x minus 5 times x minus 3. Okay, x minus 5 cancel. Do these two things cancel? No, they don't cancel. So we have x squared minus 3 all over x minus 3. And then Marlene said we can still factor the numerator. What method would I use to factor that? Is 3 a square? So we're done.
What is that? How do you factor that?
You can't. You can't factor it, so we are done. Okay, but you can't reduce it. I get a lot of times we have an x squared minus 3 and an x minus 3. So students think that this is the same as x minus 3 times x minus 3, so they cancel. It's not the same. The squared is only attached to the x, so you have to leave it like this as your answer. Okay, you are done. Right? Remember, they have to be exactly the same in order to cancel. Okay, example 5. X minus y all over 8y minus 8x. Okay, how does, the numerator does not factor, how does the denominator factor? A GCF, so this is 8 times y minus x. Okay, so in the denominator I have y minus x, in the numerator I have x minus y. Are those the same thing?
No.
No, because order does matter, but Cole made a good point. What if I factored out a negative? So if I factored out a negative from here as well, that would give me negative 8, right? And then what would happen? If I factored out a negative, positive y becomes what? Negative y. And negative x becomes positive x. Are these two the same thing? Yeah, we can reorder them to get negative 8 times x minus y. Now they cancel. So you can go ahead and cancel them. The numerator, I am left with a 1. In the denominator, I'm left with a negative 8. So our answer is negative 1 over 8. These two things have a name. They are called opposite factors. So I want you to write that in the margin. Okay. So these two things are opposite factors when we're subtracting, but the positioning of the two terms is flipped. If you factor out a negative, you can flip them so that they are the right way. So you could go straight from this step to this step. You don't have to include this step. I wanted to show it to you the very first time so you see what's going on. But these do have a name, opposite factors. So if you factor out a negative, you can flip it so that they look the same. Okay? Fine. Oh, we have one more, just kidding. Example 6. 2 plus x squared times x squared plus 6x plus 8. Okay, the numerator here, 2 plus x squared, that's already factored for us, so we can't go any farther. You can, you can expand it, though, if you would like, to make it easier for you to see. That's a 2 plus x, by the way.
They're both 2 plus x?
Well, it's 2 plus x squared, so I just expanded it out to 2 plus x times 2 plus x.
Oh, okay. I didn't know what that first thing was.
Yeah, no, I messed up. So it's just a fat parentheses. What about the denominator? How does that factor? The diamond method?
Yeah, I was gonna say that.
Okay, so what two things multiply to 8 and add up to 6? What? 2 and 4, good. So that gives me x plus 2 times x plus 4. Does anything cancel here? What? Yeah, what is it? X plus 2 and 2 plus x. Are these the same thing, guys?
Yeah.
Yeah, remember, for addition, order does not matter, so you can cancel those. So what are we left with? 2 plus x all over x plus 4. Remember, these do not reduce at all because they are not exactly the same. You cannot reduce part of it and not reduce the whole thing. So either all of it reduces or none of it reduces, because that addition is like glue. It keeps everything together. You can't separate them. Okay? Okay, so let's multiply some stuff. So, multiplying rational...
This is the same one.
Same set of notes. So step 1, you are going to factor both the numerator and the denominator. Step 2, we'll be able to cross cancel, and then we're going to multiply or simplify what is left over. Okay, example 7. 5x to the third y all over x squared y times y to the third over 15x squared. Nothing here can be factored because it's all just multiplication. So what we're going to do is we're going to cross cancel where we can. So looking at these two things, 5x to the third y and 15x squared, what do you guys see that cancels or reduces? 5 and 15. 5 goes into 15 3 times. What else do you see? X's, yeah, I have x squared and x to the third, so that actually reduces to 1x. What about in the other way across? What do you guys see that cancels there? A y, and that becomes y to the second. So what we're going to do is we're going to multiply what's left over. So I have y times y to the second. So that's going to give me x, y to the third, all over x squared times 3. So that's 3x squared. Can I reduce any more?
No.
Well, you can reduce the x's.
Yeah, I can reduce the x's again. This x cancels, and the x in the denominator just becomes an x by itself.
Oh, I thought since there's a square you couldn't do that.
Yes, you can. All over 3x. So that's your answer. So, you need to make sure in something like this, when you are simplifying, you are only simplified all the way if you have only one set of y's in either the numerator or the denominator, and one set of x's in either the numerator or the denominator. Up here we had x in the numerator and x in the denominator, so something cancels elsewhere. But you should only have y's show up once and x's show up once. Okay? So make sure that you are reducing all of the way. Alright, example 8. 3x minus 12 all over x plus 5 times x plus 6 all over 2x minus 8. Okay, our first step said we had to factor everything first, so we actually can do some factoring this time. 3x minus 12, what method would I use to factor that? GCF, so pull out the GCF of 3, that gives me x minus 4. All over x plus 5 does not factor, so we leave it as it is. Something helpful that I like to do is I actually like to put that in parentheses as well to help remind me that it stays together. Times x plus 6 does not factor, so we leave it as it is. But 2x minus 8 does factor. It's a GCF of 2. So that leaves me with x minus 4. Okay, so what do you guys see that can cancel or reduce? X minus 4 and x minus 4. Anything else? Nope. So in the numerator, we just multiply what we're left over with. You do not have to distribute or FOIL. You can leave your answer in factored form. So that's going to give me 3 times x plus 6 all over 2 times x plus 5. And that's your answer.
Wait, you distribute and then...
Okay, example 9. X squared plus 5x minus 36 all over x squared minus 49 times x squared minus 11x plus 28. Okay guys, I want to multiply these, but they are not both fractions. Can I make this guy a fraction? Yeah, put it all over what? 1. So put the whole thing over 1. And then we need to factor everything. So what I want you guys to do right now, you can work with the people next to you, factor all of this stuff right now. Alright guys. How does this guy right here, x squared plus 5x minus 36, how does that factor?
Cancel the x squared.
X plus 9 and x minus 4. Okay, how about this guy right here, x squared minus 49? X plus 7, x minus 7 times, how does this guy, x squared minus 11x plus 28 factor? X minus 7? Minus 7 and x plus... It's minus 4? Oh, both of them are negative. All over 1. Okay, what cancels here? X minus 7. Anything else? Does x minus 4 and x minus 4 cancel?
No.
No. They are both in the numerator, so they can't cancel. So we are done. So our answer would come out to x plus 9. Since we have x minus 4 times x minus 4, I'm going to write it as x minus 4 squared all over x plus 7. So, division. Division is the same steps except we have to add one at the very beginning. And that is KCF or KFC. How many of you guys have heard of that? Okay, with division, you have keep the first term, change division to multiplication, and then flip the second term. So division is the same as multiplying by the what? Reciprocal. So this is just changing it to a multiplication problem.
It's still 7.1.
So then our steps are the same. We factor both the numerator and denominator, and then cross-cancel and simplify. So the division problem is exactly like a multiplication problem. The only difference is that we have to first change it to multiplication. Then all of our steps are the same. So I want to make sure that you guys change it to multiplication before you start factoring. Because if you don't, you might start canceling stuff before you actually change it to a multiplication problem. So we're going to change it all to multiplication first, then you can start factoring. Example 10. So basically here, first thing we want to do, we have 5x squared y to the third all over x to the 7th divided by 30x y to the 4th over y to the 3rd. Do not start canceling yet. Do not try and factor yet. You first need to change this to multiplication. So this becomes 5x squared, y to the third, all over x to the seventh, times y to the third over 30 xy to the fourth. So you change it all to multiplication first, then you can start factoring and reducing. Alright guys, so looking at our multiplication problem, what reduces here? 5 and 30. 5 goes into 30 6 times. What about x's? I have an x squared and an x. Do those reduce?
Yes,
Yep.
ma'am.
That reduces, and x squared becomes just an x. And then y to the third and y to the fourth. The y to the third totally goes away, and y to the fourth becomes a y. So then we multiply straight across. So that is going to be x, y to the third, all over 6, x to the seventh, y. So we do put the numbers in front. Something that I do with my Algebra 1 is after I'm done reducing, I highlight what's left over just so that you don't forget about it. If you want to do that, you are perfectly welcome. It's a good strategy to see what's left over. Okay, have I simplified all of the way though? No. What else reduces here?
X and a Y.
X, and so that turns into x to the 6, and the y on top returns to y to the second. So our answer is y squared over 6x to the 6. Okay. So I'm skipping around just a little bit. So this is not really example 15, it's example 11. When is this statement true? So we need to check to see if this statement ever comes out to be true. 5x plus 5 all over x plus 1 equals 5. So look at the left-hand side, guys. Can I simplify that at all? I can. Look at the numerator. Does that factor? Yeah, factor out of GCF. So that's going to give me 5x plus 1 all over x plus 1. And we want it to come out to 5. Now what do you see? X plus 1 and x plus 1 cancel, right? So then that's going to leave me with 5 equals 5. Is that a true statement?
No.
Yes, it is true. So it is always true. There is one exception though. Can anybody think of what the exception might be?
Is the negative?
If what's a negative?
If it's negative 5 on top.
Take a look at the denominator, guys. What is never allowed in the denominator? You can have a negative in the denominator. What are you not allowed? 0. You are not allowed to have 0 in the denominator. So we can plug anything we want and we will get a true statement, except for what number am I never allowed to plug in, even if it does give me a true statement?
That doesn't even make sense. This is not worth anything.
Okay.
Thingy.
What is never allowed in the denominator?
Root.
0.
A root.
You are not allowed to have a root, but right now we're working with zeros. What makes the denominator 0? Negative 1. So we have to say it is always true, except x cannot equal negative 1. So you have to include that exception right there. So anytime you are dealing with a fraction, you have to make sure that the denominator will never come out to 0. So we could plug in anything we wanted for x. We will still get an answer of 5. However, we can't plug in -1 because then my denominator becomes 0. Okay? So then what about 16? When is this statement true? 3x minus 6 all over 3. What could I do there? Yep, there's a GCF. So factor out a 3x, 3, and that gives me x minus 2 all over 3 equals x minus 2. 3's cancel, so I get x minus 2 equals x minus 2. Is that a true statement? Yes. So it is also true. Looking at my denominator, am I restricted at all in the denominator? No. So it is true for all values of x. So because it's not possible for me to ever get 0 in the denominator, it is always true. Okay? On the homework for tonight, and I am going to scooch up just a bit, so we are going to backtrack a little bit. So, you will also be asked to find domains here. Remember what we're looking for in a domain. The denominator cannot equal what? 0. So the denominator cannot equal 0. That's the most important thing for us when looking for domains of rational expressions. So what we're going to do for all of these problems, and I'm only going to do 2 of them, is we take our denominator and we set it equal to 0. So, do I care about the numerator at this point? In domain? No. With a fraction, I'm only concerned about the denominator. So we take the denominator, x minus 2, and we set it equal to 0. Solve. And we get x equals 2. So what we have here, or actually we could say cannot, right? We are looking for what the denominator, what makes the whole thing 0. So what can I not plug in? So what would my domain be? All real numbers except x cannot equal 2. Because if I plug 2 in, that gives me a denominator of 0. I could plug anything else I wanted to in for x. The only thing I cannot plug in is positive 2. So all you have to do is take your denominator, set it equal to 0, and solve, and that's going to give you what you are not allowed to plug in. Okay? Alright, so let's do example 13 really quick, and then we will be done with this one. So we have x squared plus 4. That's our denominator. So get it equal to 0. So x squared plus 4, and we don't want it equal to 0, but we're going to treat it the same. How would I solve this one? Is that a difference?
Oh wait, no.
It's not a difference of squares. So what would I do? Subtract 4. So we have x squared. We do not want it to equal negative 4. What would I do next? I would take the square root. What do you guys notice? You can't have a negative and a square root. So is this even possible?
No.
No. So what would my domain be? All real numbers. We're not restricted. Okay? So this is not possible.
Wouldn't it just be not a function at all?
We're not checking if it's a function. We're checking if there's a domain. It's a function. It tells us it's a function. But we're looking for what would make the denominator 0. Because of that x squared, because it's not possible to get that x squared equal to a negative, there isn't anything that will make that denominator 0. So your domain is all real numbers. This one, number 14, you would factor. Sometimes you do get more than one thing that makes the denominator 0. Okay, so it's not always going to be just one answer. So, but your domain will always be all real numbers except for what makes that denominator 0. Okay?